Part 2 starts from here. Now the next question. Two people standing on same side of a tower in a straight line with it measures the angle of elevation of the top of the tower as 25° and 50° respectively. If the height of the tower is 70 meter, find the distance between the two people. So first of all, we need to draw the tower. This AB represents the tower, where A is the top of the tower and B is the bottom of the tower. And it is given that the height of the tower is 70 meters. So this hole is equal to 70 meter. That means AB is equal to 70 meters. Now I will consider two random points. One is X, which is nearer to the tower, and the second is the Y, which is quite far away from the tower. Now I'm going to join B, X and Y. As I've mentioned in my video of concept and explanation, that the viewer which is nearer to the observation point will be having more angle of elevation as compared to the viewer which is far away from the observation point. So as you can see here that X is nearer to the foot of the tower, that is B, and Y is far away. So the angle between the person X and the top of the tower A will be greater. So this will be 50°, whereas the angle between the Y person and the top of the tower will be lesser, that is 25°. So I'm going to draw these two angles. For that I will be joining AX and AY. So this angle AXB will be 50°, whereas angle AYX will be 25. In this question, we need to find the distance between two people. That means we need to find this distance XY. So in order to solve XY, I would be considering two triangles, that is ABX. Using this triangle, I will find the value of BX, and then I would be using the bigger triangle ABY. Using this, I will find the value of BY. So on subtracting BX from BY, I will get XY. So this is the technique I'm going to use. So let's start solving it. So first of all, I will consider triangle ABX. And if I take into consideration this angle 50, then AB represents perpendicular and BX represents base, and tan theta is the trigonometrical ratio which relates perpendicular to base. So here tan theta is equals to perpendicular upon base, that will be equal to AB upon BX, that will be equal to 70 meter upon BX. So I will now substitute the value of theta, that is tan 50° will be equal to 70 meter upon BX. On finding the values from the natural tangents, the value of tan 50 will be 1.1918, that will be equal to 70 meter upon BX. So this BX will be equal to 70 meter upon 1.1918, and on calculating this we will get BX equal to 58.7346 to be more precise. So I'm going to write the answer up to 3 decimal places after rounding off. So it will be 58.735 meters. So the value of BX is equal to 58.735 meters. Now I'm going to consider the bigger triangle, that is triangle ABY. In that also I will consider tan theta, which will be equal to perpendicular upon base. Here perpendicular will remain same, that is AB, and the base will be equal to BY. So on substituting the value of theta, it will become tan 25 will be equal to AB, that is 70 meter, and BY we need to find. On finding the value from natural tangents, tan 45 will be equal to 0.4663, that will be equal to 70 meter upon by. So this by will be equal to 70 upon 0.4663, and on calculation I will get the value of by as 150.1179. So on rounding out to 3 decimal places, it will be 150.118. So this is the value of by. Now the value of bx is equal to 58.735 meters, and the value of by is equal to 150.118 meters. So now in triangle ABY, by minus bx will give you yx or xy. This is the distance between two people. by is given as 150.118 meter minus 58.735 meters. So the value of xy or yx will come out to be 91.383 meters. So you can leave it up to 3 decimal places, that I always recommend. And if you want to write with 2 decimal places, then it will be 91.38. This 8 will not change because this digit is less than 5. So the distance between two people is 91.38 meters. Thank you very much for watching this video. For more videos, you can visit our website transelearning.com, or YouTube channel Trans eLearning, or Instagram or our Facebook. Have a great day.